So the first one says null hypothesis is mu equals 2. Our alternative is not equal to, which means what? So it gives us that this is 2.051. It's a t, which means we need what out of that? Which is, so if I use my calculator, TCDF, it gives you your -1 E99. I plug in 2.051 and degrees of freedom of 27. And that gives me what? This gives me a big number. 1 minus that gives me, which you're saying the right thing, 0.0250 or something. Which 504, I think. Questions with where I am there. But that is in one tail. So what do I actually need to do with that? 0.02504 times 2, and that gives me p value 2 times 0.02504, which is just over 5%. Which one is between 5%? Which one is this one between 5% and 10%? You'll get strange problems like this on the AP exam and on our test because there are different ways to be able to find p-value with the t-test. It's like there's a way to use the chart, which I don't explain because I think it's confusing, and there's a way to use the calculator, so they'll do something vague like this that either way works. Number 2 gives us a what? Confidence intervals. This is like the one we just did today. So I've got a line here at 1.4. I've got a line here at 3.6. My other line is going to be at what number? So whatever this number is. And where does 1.5 fall? So if it falls between, that means we failed to reject. Because it falls within the confidence interval. With this one, it gives us, we're definitely dealing with 25 minutes. This one should be an easy problem, but I told y'all you're definitely going to see stuff like this on the AP exam and our tests. What wording up there is important? They do it twice. Or, which means it's doing what? Well, of these options, which one is definitely wrong? Which ones are definitely wrong? Because it has to be equal. So I always look through problems like that really quick. Mark these out. This can't be equal. So now I only have 3 options to look at. These are all the same. Not equal to, less than, greater than. So what's my answer? This one ends up being a lot like number 1, except it's not two-tailed. This one gives us a Z test statistic, not a T. It says the alternative is greater than, so we're just shading to the right. Before I ever do this problem, which answer is wrong? Look at my picture. Which answer is definitely wrong? Because I can't shade more than 90% to the right of a positive number. And then this one, just looking it up, either using your green sheet or using your calculator, and you get what is your answer? 0.0808. The last one, wording of this one's a little bit funny. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis on the standard treatment is 2 years. So that's my what? That's probably going to be my null hypothesis, because that's what it was initially, which is more than you need to be doing there. Early in the trial, she tries the new treatment on 3 subjects who have an average survival time diagnosis of 4 years. So we end up getting an X bar of 4 years. Although the survival time has doubled, the results are not statistically significant, even at the alpha equals 0.0 or 0.10 significant slope. Why can it be this much higher and still not be significant? What have we not considered? What's going to have a big impact in our equation? What goes here? And we know our sample size is 3 subjects. What is this? What goes here? Standard deviation, and there's no telling how big our standard deviation was here, so obviously that's what accounted for it. So our results are not statistically significant, which means we initially did what? Or we did what? If they're not when is it statistically significant? So is statistically significant this one, it was not statistically significant, so our p-value was not less than alpha. Well, just looking at that really quick, it says we incorrectly used a 0.1 test when we should have used a 0.05 test. If we made our alpha smaller, would that change anything? If it already wasn't smaller than 0.10, changing it to a 0.05 wouldn't help, so it's definitely not C. Incorrectly used an alpha equals 0.10 test when we should have computed the p-value. So that's how we still compute a p-value even though we have an alpha, so that has nothing to do with it. So it's definitely not C or D. So we just have to figure out which error it is. So I always go to draw my chart. We did what if we said this one? What goes here? Which was the null hypothesis? Which error was it where we failed to reject? We failed to reject type 2. Now, I went through that one in kind of a weird way. Are there questions on number 5? Like, I went through a lot more than I needed to cover just to be able to cover some topics. Yeah.